All right, this is our backside of 7.3. We talked about this in class, but just so we've got record of it if you needed to go back. First thing we're looking at is our greatest common factor. This should say GCF, not BCF. But when we're finding greatest common factor, we're looking for the values, the numbers, the variables that we can factor out of both of our pieces. So in our first one, it's 10x and 25. And so generally what we're doing is looking at that value of 10 and saying, okay, what are our factors of 10? So 1, 10, 2, and 5. And which one of those is our greatest common factor becomes the question, which of these four factors of 10 go into 25? So 10 going into 25 doesn't work. It doesn't give us an even number. So 10 doesn't work. But 5 goes into 25 evenly. So we'd say our 5 is the number. And then while there's an x, there's not an x in my other term. So greatest common factor, again, the variables have to be present in both pieces or both terms. And so x doesn't become a greatest common factor of this one. Now, in the second, we've got y's and x's. And so being that there is x's and y's in both of these, we will be able to factor out an x and a y. Now, how many y's we can factor out is based off of the smallest number. So I have a 3 and I have a 5. So I can't take more than I have in my smaller of the two. So I can't take more than 3, but I can take or factor out a 3. Same goes for the y's. I've got 2 and I've got 1. So I can take out the 1 that's sitting here or just leave it as y. Now in this next one, I've got 8a squared and 28a to the 5th. So we're going to look at our numbers first, our 8 and our 28, and try to figure out what the greatest common factor is of 8 and 28. So we'll start with that 8. And again, think of the factors, which is 1, 2, 4, and 8. Now we have to decide which of those numbers goes into our 28. So 8 goes into 28 not evenly, so it's not 8. But 4 goes into 28. So 4 is a common factor and the greatest common factor. Now, as far as the variables, once again, I've got a's and I have them in both. So I can factor out an a, and I'm taking a to the second because while I have a to the second and a to the 5th, the a to the second is the smaller of the two. This next one, I've got numbers of 4 and 9. So my factors of 4 are 1, 2, and 4. My factors of 9 are 1, 3, and 9. And so there's no common factor besides 1, and we don't count 1 as a common factor. So 2 doesn't go into 9, 4 doesn't go into 9, 3 doesn't go into 4, 9 doesn't go into 4. So no common factor from the numbers. Now let's look at the variables. I've got an x, but no x over here. I've got a y, but no y over there. So there's variables, but I don't have the same variable present in both terms. So this one does not have a greatest common factor. The next one, number-wise, I've got a 14 and a 15. My factors of 14, 1, 2, 7, 14. None of those go into 15, though. 1 doesn't, 2 doesn't, 7 doesn't, 14 doesn't. So there's no number that is a common factor. But let's look at our variables. I've got x's and I've got y's. So I can take out an x and a y, or have a common factor of an x and a y. And again, how many we can take out? I can take out 6 x's and I can take out 8y's. Those are the smallest in each of those. The last one on this side, 12, a to the 5th, b, and 16, a to the 4th, b to the 2nd. 12 and 16, what goes into both of those is 4. Variables, I've got a to the 5th, a to the 4th, I've got b and b. So again, I've got a's and b's in both. How many a's can we have as our greatest common factor? The smallest number, which is 4. How about b's? Just that 1. Now when we scroll to the other side, we're going to be doing the same process essentially, but now we're going to actually factor these out. So not only do we need to find the greatest common factor, we also need to then determine what's left over. So we're going to look at that first one and say, okay, our greatest common factor of 10 and 12 is going to be 2. Variables, I'm going to have an a, and I'm going to have a b. Now, that's our greatest common factor. So in my parentheses now is going to be what's left after I take out that greatest common factor of 2ab from both terms. So basically now we're just going to do some division. 10 divided by 2 is 5. A squared over a is 1a left. B over b is no b's left. So now jumping over to this one, I've got 12 divided by 2, which is 6. A over a will cancel out. B squared over b will leave me 1b left. So I've got 2ab times the quantity 5a plus 6b. Now, what we know now is that if I was to distribute this back through, we would end up with the same expression we had up here. So this is expanded form. This is factored form. And again, they are equivalent. If we factored correctly and then we distribute, we should end up back where we started. All right, the next one I've got -3, 12, and -21. I need to find the greatest common factor of those, which is going to be -3. And we'll talk about that in a second. But 3 goes into 3, 3 goes into 12, 3 goes into 21. X's, I've got an x and an x and an x in all 3 terms of this trinomial. I can take out x to the 2nd as my greatest common factor of those. All right, so now what's left? When I do -3 divided by 3, that's 1. And I want that term, that first piece, to be positive. And so that's why we factored out -3 as opposed to +3, because I wanted that first term to be a positive value. If I would have only factored out +3, then I would have been doing this. I would have divided 3 by -3, -3 by +3, sorry, which would have left me a -1. And I want that first term to be positive. The other ones I'm not so worried about, but I want to make sure that first term is positive. All right, so we're doing -3x squared. X to the 4th over x to the 2nd leaves me x to the 2nd. Here we're doing -3x squared. +12 over -3 is -4. X to the 3rd over x squared is x. And then -21 over -3 is +7. X squared over x squared is nothing. So -3x squared times 1x squared minus 4x plus 7. All right, next one, I've got a 15 and a 10. What's going to go into those is 5. I've got x's on both terms, so I can take out an x, and actually I can take out x to the 2nd. And I've got a y. Now I only have a 1, but they're in both terms, so I can take out a y as well. What's left? 15 divided by 5 is 3. X to the 3rd over x to the 2nd is x. Y over y is no more y's. Minus 10 over 5 is 2. X to the 2nd over x to the 2nd goes away. Y to the 3rd over y would be y squared. The next one is only x's. So what are we going to be able to take out is x to the 8th. So I'm going to take or subtract those 8 from the 10 and be left with x to the 2nd. I'm going to take away those 8 from, or factor out those 8 from the 9, which leaves me 1x. And then here, this one's a little bit tricky because I'm going to take all 8. I'm going to take all of the x to the 8 away. But I can't just have that term disappear. So really we're doing x to the 8th divided by x to the 8th, and anything divided by itself is 1. So this is minus 1. The next one's a little bit tricky too because there's a lot of pieces here. I've got a 3 and a negative 9 and an 8 for my numbers. Again, I have to have a greatest common factor. That is, I can factor each of those pieces by. 3 and 9 are both factorable. Both can factor out a 3, but I can't factor out a 3 from 8. So as far as numbers go, there's no greatest common factor. Now, variables, I've got x's and x's, but no x over there. I've got y's, whoops, I meant to change colors. I've got y's and y's, but no y there. And I've got z's and z's, but no z there. So, again, a lot of pieces, but this is prime. Can't be factored. The only thing that you could factor out there would be a 1, and again, we won't do that. So, this last one, I've got 100 and 150. 50 is the largest value that goes into both of those. I'm going to be able to factor out a to the 7th and b to the 3rd. What am I going to be left with? 100 over 50 is 2. A to the 7th over a to the 7th is gone. B to the 5th over b to the 3rd is b to the 2nd. Subtract 150 over 50 is 3. A to the 8th over a to the 7th is a. B to the 3rd over b to the 3rd is gone. So 50, a to the 7th, b to the 3rd, times the quantity 2b squared minus 3a. All right, hopefully that helps kind of clean some of that up, and we'll continue factoring in the next one.